Effective January 1, 2014, the National Electrical Code requires the installation of arc fault circuit interrupters in all new electrical circuits that supply family rooms, dining rooms, and bedrooms. AFCIs are electrical devices that monitor the electrical current flowing through a circuit. If they detect an arc fault, which is a dangerous electrical discharge that can start fires, they will trip and shut off the power. Arcing faults are one of the leading causes of electrical fires in homes. They can occur when damaged wires, loose connections, or other electrical malfunctions create a spark or arc. AFCIs are designed to detect and interrupt these arcs before they can cause a fire. The 2014 National Electrical Code requires the installation of AFCIs in the following areas: family rooms, dining rooms, bedrooms, living rooms if the circuit is shared with a bedroom, unfinished basements if the circuit is shared with a bedroom. The AFCI requirement applies to all new electrical circuits installed after January 1, 2014. It is not required to retrofit AFCIs in existing homes. However, it is recommended to install AFCIs in any new circuits or when replacing old ones, especially in areas where there is a higher risk of electrical fires, such as bedrooms. AFCIs provide several benefits, including increased protection against electrical fires, early detection of electrical problems, reduced risk of injury or death from electrical fires. AFCIs are typically more expensive than traditional circuit breakers. However, the added cost is worth the peace of mind and increased safety they provide. An arc fault is an unintentional electrical discharge between two or more conductors. These faults can occur when insulation breaks down, wires become loose, or corrosion develops at connection points. The high temperatures generated by arc faults can ignite surrounding materials, leading to fires. Standard circuit breakers are designed to protect against overloads and short circuits, which involve high currents. However, arc faults often involve low currents that may not be detected by standard circuit breakers. This is where AFCIs come in. AFCIs are specifically designed to detect the unique characteristics of arc faults, such as the erratic current flow and high-frequency noise. When an AFCI detects an arc fault, it quickly trips, interrupting the circuit and preventing a fire from starting. There are two main types of AFCIs: branch circuit AFCIs and combination AFCIs. Branch circuit AFCIs protect against parallel arcing faults, which occur between two different conductors. Combination AFCIs protect against both parallel and series arcing faults, which occur within a single conductor. Combination AFCIs offer more comprehensive protection and are generally preferred. The National Electrical Code specifies the types of AFCIs required in different locations. For example, combination AFCIs are typically required in bedrooms, while branch circuit AFCIs may be acceptable in other areas. It is important to consult the latest edition of the National Electrical Code to determine the specific AFCI requirements for a given installation. Installing AFCIs is relatively straightforward, but it is essential to follow the manufacturer's instructions and all applicable electrical codes. Firstly, turn off the power to the circuit at the main breaker panel. Secondly, remove the existing circuit breaker. Thirdly, connect the AFCI to the circuit breaker panel according to the manufacturer's instructions. Fourthly, connect the neutral wire to the neutral busbar. Fifthly, connect the ground wire to the ground busbar. Sixthly, test the AFCI to ensure it is working properly. When testing the AFCI, press the test button on the device. The AFCI should trip, indicating that it is functioning correctly. If the AFCI does not trip, consult the manufacturer's instructions or contact a qualified electrician. AFCIs are designed to protect against arc faults, but they are not a substitute for proper wiring practices. It is essential to ensure that all electrical connections are tight, that insulation is in good condition, and that wiring is protected from physical damage. Regular electrical inspections can help identify potential problems before they lead to arc faults or other electrical hazards. In addition to installing AFCIs, there are other steps you can take to reduce the risk of electrical fires in your home. Firstly, check electrical cords for damage and replace them if necessary. Secondly, avoid overloading electrical outlets. Thirdly, use extension cords sparingly and never run them under rugs or furniture. Fourthly, keep flammable materials away from heat sources. Fifthly, install smoke detectors on every level of your home and test them regularly. AFCIs are an important safety device that can help prevent electrical fires. By understanding what AFCIs are, why they are needed, and where they are required, you can take steps to protect your home and family from the dangers of arc faults. The National Electrical Code, or National Fire Protection Association 70, is a regionally adoptable standard for the safe installation of electrical wiring and equipment in the United States. It is part of the National Fire Code series published by the National Fire Protection Association, a private trade association. Although the National Electrical Code is not itself a law, it is commonly adopted by states and municipalities in an effort to standardize their enforcement of safe electrical practices. In some cases, the National Electrical Code is amended and modified by local jurisdictions. The National Electrical Code is updated every 3 years. The latest edition is the 2023 National Electrical Code. The National Electrical Code is organized into chapters, articles, and sections. Chapter 1 covers general requirements such as definitions, wiring methods, and equipment grounding. Chapter 2 covers wiring and protection, including overcurrent protection, grounding, and surge protection. Chapter 3 covers wiring methods and materials, including cables, raceways, and conductors. Chapter 4 covers equipment for general use, including appliances, lighting, and motors. Chapter 5 covers special occupancies, including hazardous locations, healthcare facilities, and recreational vehicles. Chapter 6 covers special equipment, including electric signs, electric welders, and X-ray equipment. Chapter 7 covers special conditions, including emergency systems, fire alarm systems, and communications systems. Chapter 8 covers communications systems, including telephone, data, and cable television. Chapter 9 contains tables and examples. The National Electrical Code is a complex document, but it is essential for anyone who works with electricity. It provides the information needed to install electrical wiring and equipment safely. The National Electrical Code is available for purchase from the National Fire Protection Association and other retailers. It is also available online through various subscription services. In addition to the National Electrical Code, there are other resources available to help you learn about electrical safety. These resources include books, articles, websites, and training courses. It is important to stay up to date on the latest electrical safety information. Electricity is a powerful force that can be dangerous if not handled properly. By following the National Electrical Code and other safety guidelines, you can protect yourself and others from electrical hazards. The scope of the National Electrical Code is broad, covering electrical conductors, equipment, and raceways, signaling and communications conductors, equipment, and raceways, and optical fiber cables and raceways installed indoors and outdoors, public and private premises, including buildings, structures, mobile homes, recreational vehicles, and floating buildings, yards, lots, parking lots, carnivals, and industrial substations, installations of conductors and equipment that connect to the supply of electricity, installations used to export power from or import power to a building or structure, and overhead or underground conductor runs. The National Electrical Code does not cover ships, watercraft other than floating buildings, aircrafts, railway rolling stock, or automotive vehicles other than mobile homes and recreational vehicles. It also does not cover underground mines, self-propelled vehicles, or installations under the exclusive control of an electric utility. The National Electrical Code contains many important requirements for electrical safety. These requirements are designed to protect people and property from electrical hazards. The National Electrical Code is constantly being updated to reflect new technologies and best practices. It is important to stay up to date on the latest changes to the National Electrical Code. The National Electrical Code is an essential resource for anyone who works with electricity. By following the National Electrical Code, you can help to ensure that electrical installations are safe and reliable. AFCIs are a critical component of modern electrical safety. Their ability to detect and interrupt arc faults before they can cause fires makes them an essential safety device for homes and businesses. By understanding the requirements for AFCI installation and following proper wiring practices, you can significantly reduce the risk of electrical fires and protect your property and loved ones.